right. Today we are learning about sine, cosine, and tangent ratios, everybody. First, we're going to start off by reviewing what opposite, hypotenuse, and adjacent mean. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent represents opposite over adjacent. These are the three trig ratios that we can use to solve a right triangle. And right ratios of right triangles, finding sides and angles of right triangles. So first of all, the leg that is opposite to angle B would be the opposite side of the triangle, which is AC. The side that is the hypotenuse would be AB, because that's opposite of the right angle. And then the leg that's adjacent means next to or touching, so the adjacent leg would be this one, which is BC. The adjacent leg also is the one that is not opposite. So if this is opposite, BC is the adjacent to angle B. Here from angle D for both of these, the length of the opposite leg, here's angle D, so the length of the opposite leg would be 4. The length of the hypotenuse would be 5, and the length of the adjacent leg would be this one right here, because it's touching angle D, and that is 3. On this side, we're writing the ratios, which means a fraction of opposite divided by the hypotenuse. So if the opposite is 4 and the hypotenuse is 5, the opposite over adjacent is 4 over 5. The ratio of the adjacent leg to the hypotenuse would be 3 over 5. And the ratio of the opposite to the adjacent would be opposite is 4 and adjacent is 3, so 4/3. In the second triangle, we're looking at angle G for both of these. So the opposite leg to angle G is 12, because that's opposite of angle G. The hypotenuse is 15. And the adjacent leg would be 9, because that's the leg that's touching it. So then we can find the ratios of the opposite to the hypotenuse. So that would be 12 is opposite, 15 is hypotenuse, and 12 over 15 is 4/5. The adjacent to the hypotenuse, the adjacent side is 9, and the hypotenuse is 15, so that'd be 9 over 15, which is 3/5. And the opposite to the adjacent would be 12 divided by 9, and 12 over 9 is 4/3. One thing that you can notice is that these ratios are both the same. And the reason is because this triangle is this triangle multiplied by 3, which means that they're similar triangles. And similar triangles have the same angles, therefore they will have the same ratios. And that's how your calculator knows that if you type in an angle measure or if you type in a ratio, it will give you the corresponding angle measurement or ratio.
Don't find out this.
So the summary of sine, cosine, and tangent is that sine is the opposite over the hypotenuse. Cosine is the adjacent leg over the hypotenuse, and tangent is the opposite leg over the adjacent. As long as you know this abbreviation, SOHCAHTOA, this mnemonic, you can remember these three trig ratios: sine, cosine, and tangent. So let's do some more practice. Here is sine of B. Angle B is this angle. Sine is opposite over hypotenuse. The opposite side is 8. And the hypotenuse of this triangle on the right that we're looking at is 16. Cosine of D, well, D is the angle over here on this triangle. So cosine is adjacent over hypotenuse, and the adjacent side is 8, and the hypotenuse is 8 square root 2. Since you can simplify the 8s, it becomes 1 over the square root of 2. The tangent of D would be opposite over adjacent because of the TOA, which is 8 is opposite and 8 is also adjacent. And 8 divided by 8 is 1. Fun fact, since this is 8 and 8, this is an isosceles triangle, which means these two angles will be the same and both 45 degrees. So the tangent of any 45-degree angle is always going to be 1, because you're always dividing the same side lengths together. Here, DAC would be DAC, so right here, and sine would be opposite over hypotenuse. The opposite side is 8, and the hypotenuse of that triangle is 8 square root 2, which would reduce to 1 over square root 2. Tangent of B, well, B is back at this angle, and the tangent would be the opposite, which is 8, over the adjacent, which is 8 square root 3, and like the other one, that simplifies to 1 over the square root of 3. Cosine of angle BAC, well, BAC is, if we follow the letters, trace over BAC, A is the angle we're looking at, and the cosine is adjacent over hypotenuse. The adjacent side to this angle would be 8 because it's next to it rather than opposite of it. And the hypotenuse of that triangle is 16, which reduces to 1/2. Sometimes we will just be needing to type the angle into our calculator like this. So one thing you need to know is that your mode in the calculator to answer these questions needs to be in degrees. Radians is something different that you learn about in the future class, but you want to make sure that the degree is highlighted. So once it is, you could press second quit and then start typing in these numbers and round to 2 decimal places. So sine of 60 would be 0.87. Tangent of 45 is 1, just like we talked about earlier. The cosine of 30 is also 0.87, and the reason is because these two angles are complementary, and in a triangle, sine of one angle is the same as the cosine of the other angle. Tangent of 52 is 1.28. Sine of 64 is 0.90, and sine of 130 is 0.77. Even though you can't have an angle that's 130 degrees in a right triangle, the reference angle would be the difference between 180 and 130, which is 50. So if you found the sine of 50, it would be the same thing. So you write those in your answers. The next problem we're going to do involves something that you need to know for your project. So I'm going to draw a x and y axis and plot the coordinates 6, 0, which is right here, negative 4, 2, 1, 2, 3, 4, 1, 2, and there's B, and then C is 0, 6, 1, 2, 3, 4, 5, 6. So one of the reasons I know that this is a right triangle is because if it was a right triangle, then we would have a right angle, which means that these two sides would be perpendicular, and if they're perpendicular, then the slopes are opposite reciprocals. So the slope of this segment is 1, while the slope of this segment is negative 1. Now I know that they are opposite reciprocals, because you go up 4 over 4, down 6 over 6. Then we would find the side lengths, which is what we did the day before, where you can make mini right triangles going up and over. So if I go up 4 over 4 and do 4 squared plus 4 squared equals BC squared, and then take the square root of that, you would find the answer for BC, which is BC is 5.66. So if you do that for all 3 of those side lengths, I'm going to make this video a little bit shorter and just tell you what you would get. You would get 8.5 for the longer leg and 10.2 for the shorter leg. Next, we're going to use this table here. I'm going to come up to find the sine, cosine, and tangent ratios of both angles. And we're going to notice some important things. So the sine of B is opposite over hypotenuse. Opposite side would be 8.5, and hypotenuse is 10.2. And if I divide those two numbers in my calculator, just no sign, just divide the two numbers, you'd get 0.83. The cosine of b would be 5.66 over 10.2, and if I divide those two numbers in my calculator, we would get 0.55. The tangent of b would be the opposite side, which is 8.5, over the adjacent side, which is 5.66. And 8.5 divided by 5.66 is equal to 1.50. Now I want you to do something. Divide 0.83 by 0.55 in your calculator. And let's notice something. 0.83 divided by 0.55 is also 1.5. We're just going to call that 0 for now. 1.5, which is the same as this. So we have an interesting formula here. The tangent of any angle is equal to the sine of the angle divided by the cosine of the angle. Because you're basically taking the opposite over adjacent. Since the hypotenuses are the same, they are going to cancel out. So that's one important formula that we have. The other one we'll get from looking at this. So sine of A, now we're looking at this angle. Sine of A is opposite over hypotenuse, which is 5.66 over 10.2. But we just found that over here when we were doing cosine of B. Remember how we said sine of A equals cosine of B? Sine of B is the same as cosine of A. So these are just flip-flopped because the opposite of one angle is the same as the adjacent of the other. So that's 0.55. For cosine of A, we know it's just going to be 0.83. But it's not the same for tangent. So for tangent of A, the opposite side is 5.66, while the adjacent side is 8.5. So although it's not the same, they are what we call reciprocals of each other, which means that the fractions are flipped. And if I know that 1.5 as a fraction is 3 over 2, the reciprocal of that would be 2/3. And let's just type it into our calculator to double check. So 5.66 divided by 8.5, and we would get 0.66. And the reason it's not 66 repeating is just because we're rounding these numbers, but it is an exact reciprocal if you didn't round. Okay, so one other important thing that you need to know for your project and articulate is that the tangent of one angle is the reciprocal, which is represented by 1 over the tangent of the other angle. And that is the end of this lesson. In the future lessons, you'll learn how to solve with these ratios, side lengths, and angle measures.